Okay, so what I thought I would do is maybe 3 problems that would help you get going on the assignment in case you get stuck. I thought what I would do is maybe problem 7 and start off with that one, and then we'll do a couple other problems like, number 17 and also number 22. So I think what I'll do is I'll just do a little trick here. I'm going to capture some of these problems. Let's go right here. And I'll do that. Okay, so move that out of the way. Okay, so number 7. Okay, so we're going to do f of x minus g of x. Well, these are the two functions written right up here, so all we need to do is substitute them in. So f of x we're going to put in right there, and g of x we're going to put in right there. Now you have to watch out for this negative. A lot of people make a mistake right there. So this is what I recommend. We'll go ahead and start out negative 3x to the 1/3 power plus 4x to the 1/2 power. And I recommend writing this negative right here and then put parentheses around g of x. So I'm going to put 5x to the 1/3 here, and then plus 4x to the 1/2 power. Alright, and what a lot of people do is they don't use the parentheses, and so they do something like this. They put that negative with just the first term here. So if that negative's not there, they put it with just that one. Well, what are we supposed to do? We're supposed to be subtracting g of x, which means we need to subtract the entire function. So the negative goes to that one, and it goes to that one as well. So please avoid that mistake by putting in parentheses. And then distribute the negative to both terms here. Okay, so hopefully that makes sense. And so what I would do is just rewrite this, and I get negative 3x to the 1/3 power. I get plus 4x to the 1/2 power, and then minus 5x to the 1/3 power, and minus 4x to the 1/2 power. Okay, well, these two terms are like terms, and they are opposite in sign. One's positive, one's negative, so they just kind of cancel out. And then these two are also like terms, and so we get negative 8x to the 1/3 power. Now, be careful here. Well, what we're doing basically is adding two negatives. So when you add two negatives, you get a bigger negative. So anyhow, that's our answer. Now be careful. Make sure you do state the domain. Now the domain is a little bit tricky because if you look at this, the values of x look like they could be positive or negative. Like we've done cube roots before. You can do the cube root of 27, for example, and you get 3. And you can also do the cube root of negative 27, and you get negative 3. But here's the thing that's tricky. What we started out with was this expression right here. And it turns out there's restrictions on this one right here. And there's a restriction on this one right here as well. So g of x and f of x both have a domain restriction because of that one. So what that means is we have to restrict our main domain to this here. And if we're taking square roots, we cannot take the square root of a negative number. Keep in mind here that square root of x is equal to x to the 1/2 power. That's equal to square root of x. And you might recall some of the other ones. X to the 1/3 power is equal to the cube root of x. So the thing to remember is if the index here is like a 2 or a 4 or a 6 or so on and so forth, then you always have to restrict the domain. And so we cannot take the square root of like a negative number. Okay? So anyhow, because of that, we have to restrict our domain. And so the domain for this one is, we could state it like this, domain x is equal to all real numbers such that x is greater than or equal to 0. Okay, now lots of times if you look up answers in the back of the book, they'll just write this here. That's okay sometimes, but it's probably better to be a little bit more specific and just simply say x could be all real numbers such that x is greater than or equal to 0. Okay, so that takes care of number 7. Let's move on. And erase some stuff here. And we'll try number 17. Okay, so number 17 now. On this problem, we're doing a quotient, so we're doing g of x divided by f of x. And our functions are sitting right here, so g of x is equal to 5x to the 1/2 power. We're dividing by 4x to the 2/3 power. Okay, well, when we try to simplify this, I don't see a whole lot to do with this 5 and the 4. There's no common factors to cancel out. But the x's here, since we have a quotient here, we want to use the property of exponents for quotients. And that said something like if you have x to the m over x to the n, then what you have to do is subtract the exponents. So you get x to the m minus n. And that's what we need to do here. So let's continue. The 5/4 is going to remain the same, so we get 5/4. And then we have this x to the 1/2 power minus 2/3. Now, if you're not very good with fractions, that's fine. Use the calculator. There's nothing wrong with that. But if you want to try this out with fractions, well, go ahead. What we should do is get a common denominator because we cannot add or subtract fractions until we get a common denominator. So we're going to write this as like 6 and another 6. And what we need is a 2 here. So we get a 2 here. So we get 4. And we have the minus. And we're going to need a 3 here and a 3 here. So we get 3, 6 minus 4, 6. And of course that's just equal to negative 1, 6. Okay? So the bottom line is that this simplifies to 5/4 x to the negative 1/6 power. Now most of the time we're expected to simplify these exponents to the point where there's no negative exponents. So in this case what we could do is another property of exponents. We can move this down to the denominator. Right now it would be in the numerator. So we're going to bring it down so that's with this 4 here. So what we get then is 5 over 4x to the 1/6 power. And there you have it. We have that one. Now be careful. Make sure you state the domain. If you're not doing the domain on these, you're going to lose about half credit. So since this is 6th it's the same thing as like a sixth root of x. And so again, we cannot allow these numbers to be negative. And so normally what we'd say is the domain for this one, we're going to say x is equal to all real numbers. Remember, there's like a double downstroke. Such that and we need x to be greater than or equal to 0. However, there's one other little subtle thing here. This x is in the denominator, and so we cannot allow 0 to be down here because that would cause a division by 0 error. So what we need to do to fix our domain is just simply take that equal sign off of there, and now the domain would be correct. So there you have it. Be careful, make sure you're doing the domain in all your problems on the ones that they ask for it anyways. And there you have number 7, number 17. And now what I'd like to do is number 22. So let me just clean up some space here. And we'll do number 22. Okay, so 22. What we have on this one, well, notice there's 3 functions. There's f of x, there's g of x, and then there's h of x. And in this one, we don't have to find the domain. So, but what we're after is h of f of negative 9. So, now for these problems, what I recommend is that you work on the inside first. So I would just go ahead and calculate f of negative 9. So f of negative 9, I'll just do that first. And I'll kind of do that on the side here. And then we'll simplify that. Okay, well remember, we're finding f of x. And we're going to plug in negative 9. So what I like to do is write down the rule, 3x plus 2. And then now you have a little framework to put this in. Whatever number is here goes in for x. And so in this case, we have f of 9, f of negative 9, is going to be equal to 3 times negative 9 plus 2. And of course, that equals negative 27 plus 2. This looks like it's negative 25. Okay, so that's what f of negative 9 is. Okay. Now here's what you do. Take this and put it in right here. So you no longer have that part. You have negative 25 instead. Okay? Does that make sense? Now to do that, I'm going to go ahead and write down what h of x is. Now, I have is this function right here. So it's equal to x minus 2 over 5. And whatever's here goes in for x right here. You see? So in this case, we're going to have negative 25 minus 2 over 5. And then that, of course, is just simply equal to negative 27 over 5. Okay, so I just want to add one little bitty note. Sometimes we'll rewrite it the original way it was written before the substitution. So we sometimes might rewrite it this way. H of f of negative 9 equals negative 27 over 5. Okay, but as far as working it out, I think it's easier, like I said, just calculate this on the side like we did right here, and then substitute that in. And it might make that a little bit easier for you. Okay, well there you have it. I hope that's some help for you, and I hope you can get through half of the assignment. And then, like I said, we'll do the other half tomorrow in class. Bye for now.